This is the lesson for 2-1 day 2. What we're doing today is we are identifying the rate of change, using it to write an equation, and using the equation to find solutions. First of all, your rate of change is your slope. When we write the generic form of the equation of the line, it is y equals mx plus b. That m is your slope. It's the number that goes in front of your x. We can also recognize rate of change in word problems with the word per, each, every, or some other context clues. Some examples of some rates of change might be the following. You might have something like miles per hour. That is the rate of change, miles per hour. Or we might have like sit-ups per minute. Or maybe we're talking about scoring goals in a soccer game. Maybe you scored 5 goals. Maybe a team scored 5 goals per game. And other various things like that. Maybe in a hot dog eating contest, somebody ate 10 hot dogs every 3 minutes. Things like that. That is your rate of change. It's how fast something is happening. So given a linear function, we need to identify the rate of change, the input, and the output. Belinda is making greeting cards. She makes 4 cards per hour. That's your key right there. The function c of t, cards in terms of time, equals 4 times t. So represents the total number of cards Belinda makes as a function of time. The input value is your t. The output value is 4t. So the rate of change is 4 because you're making 4 cards per hour. If we're talking about a teacher grading quizzes and found that she graded 12 quizzes per hour, the T would be your input. The output is 12t, and your rate of change, or your rate, is the 12 per hour. So what are we going to do with this? We're going to look at a question and find some values, all right? Now, your independent quantity is your input. Your dependent quantity is your output. So it says a 747 airliner has an initial climb rate of 1,800 feet per minute. That means it's going up 1,800 feet every single minute until it reaches a height of 10,000 feet. That's the highest that it's going to be. So your rate of change is 1,800 because it's going up 1,800 feet per minute. Therefore, our equation would be y equals, or f of x equals, y equals 1,800 times x. That would be our equation. You might refer to it as, instead of f of x, height in terms of time. And then we would use 1,800 t. Whatever this letter is has to match this letter. So if we're talking about time, we need to use t in our equation. For quantity, quantity is like the generic form, and units is the more specific. So for our independent, independent is always time. Independent is always time. And how are we measuring time in this problem? We're measuring time in minutes. The dependent quantity is the thing that is changing. So the thing that is changing is the height of the plane. How are we going to measure the height specifically? Specifically, we're going to measure the height in feet. So when I take a look at my expression, an expression doesn't have an equal sign. I'm just going to take the tail end of my equation here and put it as my expression. So it's in form of t, so I'm going to write 1,800 t. That's going to be my expression. Now, how do you find 0, 1, 2, 3, 4, 5? How do you find those? There's a couple different ways to do it. One of the ways to do it is to take these numbers and sub them in to our expression or our equation. So you're going to do 1,800 times 0, 1,800 times 1, 1,800 times 2, 1,800 times 2.5. But there's another way on the calculator that you can find these out without having to do them by hand. What you're going to do is you're going to go to your y equals, and you're going to type in your expression. So I'm going to type in 1800. Now there's no t on the calculator, so I'm going to type in 1800x. I'm going to use the table function. So the table function is that blue function right above graph. So I'm going to go second and graph, which is really my table. Now notice that the x column counts by ones. That helps me out for these. So 0 is 0, 1 is 1800, 2 is 3600, 3 is 5400, 5 is 9000. Now there is a way to get the 0.5s as well without having to sub them into the equation. What you're going to do, notice that at the top above the x and the y, it says press plus for the changing the table. So if I hit plus here, notice it says table, and the table is counting by ones. Well, I could change that to be 0.5. So if I change it to be 0.5 and I hit enter, now notice that it's counting by 0.5s. Since it's counting by 0.5s, now I have 0.5, 1.5, 2.5, so I can use those in my table. So this is 4,500 and 3.5 is 6,300. So that's an easy way to get the values for your table, or you could just sub them in by hand and sub them into the 1800. So that's one way to do it. Let's take a look at another one. So Miguel is riding his bike to lacrosse practice at a rate of 7 miles per hour. Well, if we're taking a look at 7 miles per hour, our quantity, our independent quantity, again, that's almost always time. How are we measuring time in this question? We're measuring it in hours. The dependent quantity is the thing that's changing. Well, if he's riding his bike at a rate of 7 miles per hour, he's going farther and farther and farther and farther. So the thing that is changing is the distance that he is traveling. How are we measuring that specifically? We're measuring it in miles. So for the expression, all right, we're going to measure that in hours, all right? And it's going to be 7 miles per hour. So that's going to be 7 times the number of hours, because he's going 7 miles an hour. So 7 times 1 hour, he would go 7 miles. 7 times 2 hours, he would go 14 miles. 7 times 3 hours, he would go 21 miles. Again, to find these, you can do it in 2 ways. You could just sub that right in for the h. So we'd have 7 times 0, 7 times 0.5, 7 times 1, 7 times 1.5, 7 times 2. Or we could use our calculator. We could go to y equals. We could type in our expression. All right, our expression is 7 times h. I need to clear out these other things that are here. So 7h or 7x, because there is no h on the calculator. And then hit second and table. We still left it as counting by 0.5s, but if we wanted to change it back to counting by ones, we'd have to hit the plus sign again. So there's my data. 0 is 0. 0.5 is 3.5. You go 3.5 miles in a half an hour. 7 miles in 1 hour. 10.5 in 1.5 hours. And 14 miles in 2 hours. If we had to write an equation for this one, I would write it like this. Distance as a function of hours equals 7h. That would be my equation if they asked you to set up an equation. So the next thing that we're going to talk about is, given a function f of x equals 12, what does f of 3 mean? Well, f of 3 means that x equals 3, and you're going to sub in a 3 for your x. So if we have f of x equals negative 10, all that I'm going to do is take this number that's inside the parentheses and sub it in for x. So instead of negative 10 times x, I'm going to have negative 10 times 8, which would give us negative 80. F of x equals 1.2 times x. We want to know the f of 3.4. So you take that and sub it in for x. So we'd have 1.2 times 3.4, which would give you 4.0. 0.08. F of x equals negative 10x. We want to know the f of negative 2.35. Sub that in, so negative 10 times negative 2.35, and you would get 23.5. The last one is finding solutions graphically. So we have the graph now of our airplane. Notice that we're still going up at 1,800 feet per minute. Use the graph to determine how many minutes it would take for the plane to reach its height. So we want to know the height, we want to know how many minutes it's going to take to get to 5,400. Well, what I'm going to do is I'm going to go to my graph, I'm going to go to 5,400 and then go over. My graph for this hits right there. So if I go down to look at where it is, it's at 3 minutes. So you want to go to where 5,400 is, go to where 3 is, and see where they come together on that line. 9,000. Now, our y-axis is counting by 900, so I know that that's 9,000. I'm going to go from 9,000, go over until I hit my graph, which is right here, go straight down, and that's at 5 minutes. Now, sometimes they will ask you to make an estimate. That's what they're going to do in this C question. In the C question, they're asking you for 3150. So if I go to 3150, I have to make an estimate of where 3150 is. I'm going to say that it's right about there. Oh, that's a little bit high. Right about here. And so I'm going to go to 3150 and I'm going to go over to my graph. Now, if I go straight down from there, it looks like it's a little bit after 1.5, but it's definitely before 2. If I had to make an estimate, I might say that it's at 1.75 or maybe 1.8 or maybe 1.7. You don't really know. Sometimes you just have to make an estimate. But could we find it out exactly? We could find it out exactly by subbing it into the equation, right? We know that we're at 3150 for our height. So that's what that number is. So we could really take and do 3150 equals 1,800 t, so that we could find the time. So you would have to divide, it's just a one-step equation, divide by 1,800, divide by 1,800. 3150 divided by 1,800 gives you 1.75 equals t. So that is where 3150 is. It's at 1.75 minutes. Now, again, I looked at my graph and I saw that it was right here. And you can tell that it's a little bit past 1.5, but before 2, but you don't know for sure. To know for sure, you'd have to sub it in. But sometimes they just have you make a guesstimate of where it is. Take a look at 4,500. 4,500 is here. If I go straight across on 4,500 to my graph, and then I go straight down from there, it's somewhere in between 2 and 3. I don't know where for sure. It's somewhere in between 2 and 3. If I had to take a guess, I'd maybe guess about 2.5 because it looks almost halfway. But let's see for sure. 4,500 equals 1,800 t. Divide by 1,800, divide by 1,800. 4,500 divided by 1,800. Oh, I'm a good guesser. It is exactly 2.5. So this would be at 2.5 minutes. But again, sometimes they make you look at the graph and just look where it is from the graph. This time we're looking at the h of t, which is the same thing as the y, right? We're trying to find the x value. And that is the lesson for 2-1, day 2. Again, use your calculator to try and use the table function. It makes it a lot quicker and makes it a lot easier so you don't have to sub them in by hand.